To find the formal charge for each element in CH2O, formaldehyde, we have a Lewis structure here, and then we have this formula. So let's look at the hydrogen first. Hydrogen, that's in group 1 on the periodic table. It has 1 valence electron. We'll subtract the unbonded valence electrons. All of the electrons around hydrogen, they're involved in the chemical bond between the hydrogen and the carbon. So we don't have any unbonded electrons. Then we'll subtract 1/2 of the bonded electrons. These are the electrons here involved in the chemical bond between the hydrogen and the carbon. This line here represents a pair of valence electrons. So we have 2 of those there. 1 minus 0 minus 1, that's 0. So the formal charge on the hydrogen, that's 0. And since this hydrogen's identical, it's also 0. Next, let's do the carbon. Carbon, that's in group 14, sometimes called 4A. On the periodic table, it has 4 valence electrons. We'll subtract from that the unbonded valence electrons. And again, all the electrons around the carbon, they're involved in chemical bonds with the hydrogen atoms and the oxygen. So we don't have any unbonded electrons. Then we subtract 1/2 of the bonded. We have 2, 4, 6, 8 of those. 4 minus 0 minus 4, that equals 0. So the formal charge on the carbon, that's 0. Last, let's do the oxygen. Oxygen, group 16 on the periodic table, 6 valence electrons. Unbonded, we have 2, 4 of those. We'll subtract 1/2 of the bonded valence electrons, these here. So we have 2, 4 of those. 6 minus 4, that's 2, minus 2, that equals 0. So the formal charge on the oxygen, that's going to be 0. When we're working with formal charges, we'd like to have the formal charges as close to 0 as possible. That means that this would be the most likely or favorable Lewis structure for CH2O. This is Dr. B with the formal charges for each element in CH2O, formaldehyde, and thanks for watching.